So vectors in three dimensions. Well, before looking at vectors, actually, we are going to look a little bit at geometry and some notation symbols, and well, understand what the three-dimensional coordinate system looks like. We're going to plot a few points. Well, actually, we're really not going to plot points in three dimension. It's not that easy because we need to have a sense of perspective, and well, I guess art majors are really the best ones to do this. Architecture majors are the ones who can really do better. But of course, we're going to look at a couple examples just so you get a feel of what really is. So the three-dimensional rectangular coordinate system, typically denoted with this stylish R, means all real numbers that are in the 3D space. Okay, R3. And as opposed to the usual XY plane, the 2D plane is the 2D plane or 2D system is R2, all right? Or the real number line is just R, all the set of all real numbers. The right-hand orientation. So when we try to plot anything in 3D, we use some perspective. This is the x-axis, this is the y-axis, and this is the z-axis. And well, the right-hand orientation is, well, for example, if you do this, if you point this as your x-axis, the direction when I fold my fingers, that's the direction where the y-axis is. And if it's upside down, well, that's where the negative y-axis is going to be. Okay, and this will be very, very important in the next section when we do the vector product, the cross product. Well, you'll see that. Well, from this system, let's break it up into its main components. You know, we have different coordinate planes. So this one right here in blue is the system that you have worked throughout all your math courses, you know, the XY plane. So this is the first time that you will see the z-axis right here. And in this case, we have the XY plane. All right, so XY plane, and in this case the value of, so if we were to describe the points that live on that plane, well, in this case we're no longer going to use ordered pairs, we're going to use ordered triples. These ordered triples will have a z equals to 0. Now, let's look at the second plane. The second plane includes the x-axis and the z-axis. And if you look at this plane, well, it's not a solid region. It's also, in this case, it's y. All the y's would be 0, so that's the xz plane. And last but not least, the yz plane, where in this case, x is equal to 0. We're going to look a little bit more about other regions in 3D. So you might remember from Calc 2 and from pre-calculus, the conic sections, parabolas, ellipses, all those. Well, in 3D, we're going to look at very similar solids like ellipsoids, cylindrical hyperboloids. Well, they have weird numbers, and we're going to look at those equations, and you'll see later when we get to those sections. Okay, so in the meantime, let's plot the points 2, 3, 5, -3, -6, -4. All right. So again, we need some sense of perspective to plot this. All right. So this is x, this is y, and this is z, and let's scale them. Right? Okay, so in the same way that we plotted points in 2D, 2 units in the x direction, 3 units in the y direction, but in this case we add 5 units in the vertical direction and the z direction. So let's go about this by, so 1, 2, And then, so from here, we need to move 3 units in the y direction. 1, 2, 3. But we need to keep the perspective with respect to the x-axis. Like this. And then from here, I'm going to go 5 units up. But I need the perspective with respect to the c-axis, which is kind of weird. So I need to go 1, 2, 3, 4, 5. And I think it's going to go here. So 2, 3, and 5. Alright, so do you see how complicated it is to plot points in the 3D space? And it's even weirder when we have negative values here. Whoops. So 2, 3, and 5. Alright? So for negatives, we need to extend with dashed lines. We need to extend the axis towards their negative sides using dashed lines. And in this case, well, we're going to go negative 3 units. And then in the y, okay, x, y, z, negative 3, negative 6, and negative 4. Alright? I know it just looks like a point in the middle of nowhere, like just like a random point. So negative 3, negative 6, and negative 4. Maybe here. Alright? I know these are weird to graph. So it's not on the exam or anything. It's not something I'm gonna ask you to do. Actually, on the homework, you will be given the picture with of course a better picture with the perspective. You will be asked to identify different planes instead of plotting points like this. Okay. So okay, what time? Okay, let's plot each plane in space. So let's do this a couple of examples, and we're almost out of time. Okay. So, in this case, they're asking us to plot 2 planes. Alright, so in this case, in the x direction, x, y, z. So in this case, they're asking us for the plane that contains all the points whose x coordinate equals to 3. So 1, 2, 3. And let's plot the plane from here using some perspective here and passing through this point. Alright? Again, these are a little bit weird to draw. We need some perspective, but the easier one to plot, I guess, is the Z1, because, well, for the Z1, 4 units up, and then that's like our plane, and that is 4 units up in this case. Of course, we're going to look at planes with intercepts in the x, y, and z direction. Those are actually a lot easier to plot. All right. And well, so just a couple of formulas in the 3D space. Well, let me just briefly mention them. The distance formula in 3D, well, it's the same, just add one term with the c component. The midpoint formula, it's the same, just add one more component for the c values. The equation of the sphere is analogous to the equation of the circle. I mean, a sphere is a solid circle, if you will. So all we need to do here is add one more term for the c component. But